All right, people. Can you hear me? Good. I see one thumbs up. If I could get a couple more faces on here, I'd appreciate it. But we'll get going anyway. I think we are recording here. Yeah. Okay. So first off, about test. Let's see. You guys just took test number 2, and overall, the class grades for test number 2 for the people that took it were quite good. The class average was like a high B plus, which was considerably higher than the class grades for test number 1, which is, if I'm recalling, was like an 83%. So my opinion is that taking the test online is actually easier for you guys than taking it in person for whatever reason. I am willing to meet with students. Can you guys mute your microphones, by the way? I hear some noise over there somewhere. So make sure your microphones are muted, please. Okay. So I'm willing to meet with students. If anyone wants to go over their test, like know what they miss. I'm not going to just post the whole test online for people to review again. But if you want to know the questions that you missed, then I'll just read the questions to you and we can talk about them over Zoom. If you want to do that, you'll have to send me an email. Yeah, that's it. Send me an email and then we can make an appointment on Zoom to talk about your test. So the goal for today is to talk about chapter 7. We're definitely getting into hypothesis testing, that is inferential statistics. We're going to start this chapter by talking about how we're going to use z-scores. How we're going to use the z-table, which we started talking about last week, to calculate probabilities. And then we are going to quickly transition to using that z-table to actually performing hypothesis tests, actually calculating inferential statistics. Before we do that, does anyone have any general questions or concerns that we should be talking about before we get into that?
For the test, after taking it, I saw my grade, but it didn't go into my exam average in my Blackboard grades.
Yes, that's a good point. Because I had to change the format from the test. The test was originally a written test, and then I had to change it to the online version. I had to create a new column in Blackboard, and it was Susan Marshall that actually organized the tests originally. That's a very good point. In fact, I should write that down. I'm gonna have to call Susan Marshall and have her rearrange that stuff. So let me see if I can get this.
Okay, cool. I was just checking. I wasn't sure.
Yeah. I think it's supposed to. All the tests are supposed to average, but because I had to create a new column, it didn't. So that's a good point that I should write down. So Blackboard test average. Good point there. Email S Marshall. Okay, good. Anything else, people, that we should be talking about here? Okay. Yes, thanks for the suggestion there. I will definitely send Dr. Marshall an email today. Okay, so yeah, chapter 7 is what we're starting today. Yeah. So here are the two main things, and I already mentioned this. We will be using the z-table to calculate probabilities. This is something we've already done in a very elementary form last week, and then we will work our way to hypothesis testing. I don't think we won't get to hypothesis testing today, but my plan is for us to start that Wednesday. Okay, so here's a little bit of a review for the z formulas that we've been using so far. We have a population of scores, and then we want to calculate a z-score for a single score, which is what this n equals 1 means right here. So if we want to calculate a z-score for a single score, the formula that we've been using right here is this one. This is the basic z-score formula, where x represents the raw score, mu stands for the mean of the population, and sigma stands for the population standard deviation. But as we're moving towards inferential statistics, the z formula that we actually care about is this one right here. And we've actually already used this a little bit. So now notice that I've replaced what used to be an x is now replaced for an m. This m means sample mean. This m right here means sample mean. This mu still means population mean. And down here, this thing, the standard deviation divided by the square root of the n, is known as the standard error. The situation in which we use this z formula is specifically where we have a sample mean where the sample size is greater than 1. You have to use this formula right here when the sample size is greater than 1.
I have a question.
Yeah.
I can't see anything on your like whiteboard, so what should I do?
Oh, you know what? I think I'm sharing the wrong thing. I'm glad that you mentioned that. Goodness. Yeah. There you go. Is that better?
Yeah, thank you.
Yes, I'm very sorry. Thank you for bringing that up. Yes, so no, I don't want to use iTunes. Okay, so once again, I'll have to say that stuff again because the wrong thing was on the was being shared. Here is the formula right here for a single z-score right here. When you have a z-score for n equals 1, we just have a population, you're trying to calculate a z-score for a single score, you use this formula right here, x minus b over sigma. But the one that we're going to care about much more is this one right here, where m is the sample mean minus mu, which is the population mean, divided by this thing down here, which is the standard error. Once again, this formula is the one that we're going to start using for inferential statistics, and it's used when we have a sample mean and the sample size is bigger than 1. So we've also seen this thing before. This is the normal distribution right here. And I believe that there was a question on the test, for instance, like what is the percentage of the distribution that is within one standard deviation of the mean? Someone remind me, by the way, what z-score represents the mean of a distribution? Can someone just shout that out? What z-score represents the mean of a distribution?
0.
0 is right, and you can see that 0 is right here in the center. And if we were calculating the percentage of the distribution, which is between -1 and 1, the answer would be 68. Technically, it's 68.26%, but approximately 68% of the distribution lies between -1, which is z-score of -1, and a z-score of +1, which is right here. So that's one type of question we can ask, is how much area is between two z-scores? But we can also ask the question of how much area is to the left of a z-score. So we could take this -1 right here, z equals -1, and we can ask how much area is to the left of z equals -1, or how much area is to the left of z equals -1.5, or how much area is to the left of z equals +1.5. And then finally, the third type of problem that we can do is we can calculate the amount of area to the right of a z-score. So for instance, someone tell me how much area is to the right of z equals 0. How much area is to the right of z equals 0? Anyone know? What percentage of the distribution is located to the right of the z-score 0?
50.
It is 50%. So this is just some review. 50% is to the right of z-score equals 0, and 50% is to the left of z-score equals 0. So that's just some basic probabilities. And this is the basic logic of what we'll be doing, is we'll be breaking up this normal distribution into different percentages. And the main way we'll be doing that is with the z-score table. If you're following along with the slides, there should be a link to a Google Sheet right here, which has a z table for you to use. I also emailed you guys z tables last week. So this is the z table that I suggest you use. There is a different version which is available on Blackboard, and you can technically use either z table, but they're slightly different. And the one that I'm going to be teaching you to use in lectures is this z table right here. So I would use this z table right here, at least when you're following along with lectures, as this is going to be the one that I'm actually going to teach you how to use. So I'm not going to read through all of this stuff right here. But these 3 bullet points right here, these represent the 3 types of probability questions that you might be asked. Number 1 is, this first bullet point, is how do we use the z table to calculate the percentage of area which is to the left of a given z-score? That's this first bullet point right here, is the amount of area to the left of a given z-score. The second bullet point right here represents the amount of area to the right of a given z-score. And then this bottom bullet point represents what you do if you're trying to calculate the percentage of area between two z-scores. So I guess I'll just mention when you're looking to the left of a given z-score, let's go ahead and look at the z-table. Here's the z-table once again, and all of these numbers in the middle represent the percentile, that is the amount of area to the left of a given z-score. So we already mentioned that, will someone remind me, how much area is to the left of a z-score of z equals 0?
50.
Once again, it is 50. So if you look up a z-score of 0, we're on the negative side, but if we look at 0, it's negative 0.0, and then we look at the top, 0, this basically represents right here. If you see that, that's 0.50000. That basically means that 50% of the area is to the left of that z-score. These numbers in the middle, they all represent percentiles, the amount of area to the left of a given z-score. If you look up 0.00, z-score equals 0.00, and then you look right here, the percentile, as someone just mentioned, is 50%. And we could do that for any z-score. We have negative 3.49 all the way through positive 3.49. So negative z-score of negative 3.49 through a positive z-score of positive 3.49. We could calculate the percentile, that is the amount of area to the left of any of those z-scores between negative 3.49 and positive 3.49. So percentiles are easy. Looking here, if you're trying to find the amount of area to the left, that is the percentile of a given z-score, just find the z-score on the table, look up the number in the middle, the number that's in the middle for that given z-score. That number in the middle is the percentile. It is the amount of area to the left of that given number. However, sometimes you might be asked to, where did my mouse go? There it is. Sometimes you might be asked to find the amount of area to the right of a given z-score. The z-table that I gave you does not directly give you the amount of area to the right of a given z-score, but the math to calculate that is very easy. If the entire distribution contains 100% of the area, and if the z-table that I give you tells you the amount of area to the left of a given z-score, the way you calculate the amount of area to the right of a given z-score is just take 1 minus the percentile which is given for that z-score. So if I ask you the amount of area to the right of a given z-score, you look up that area in the table, you look up the percentile, and then you take 1 minus that percentile, and that gives you, and it says right here, the probability of randomly selecting a z-score that is greater than the z-score. So you want to find the amount of area to the right of a given z-score, you take 1 minus the percentile for that z-score. And then the third type of problem is if I give you two z-scores and ask you to calculate the amount of amount of area between two z-scores, the way you do that is you look up both percentiles. So you look up both z-scores in your table, and you're going to see the percentile for each of the z-score. That is, you're going to see the amount of area to the left for those two different z-scores. And then what you're going to do is you're going to subtract those two percentiles from each other. And when you do that, that gives you the difference. That gives you the amount of area between those two z-scores. So here are the 3 types of probability problems that you might do, and I've given you pretty nice instructions for how you'll use the z-table that I've given you to do all 3 of these types of problems. And you won't see any other type of problems other than these 3 on the test. For instance, there's definitely problems like this on test number 3. This is something you're going to have to do. We will do some practice today. And the procedure that you'll use to calculate any probability problem using the z-table is always going to be one of these 3 right here. Moving on. So we are headed towards today doing some practice problems where we're going to use the z-table to calculate some probabilities. And my suggestion for you is to always sketch a normal curve, and your textbook kind of reinforces this. And it's something like, let me share here. So you should be able to see my the whiteboard now. And so what I mean by is sketching a normal curve like this. And let's say I'm doing a problem where I'm asking you, well, first off, z equals 0 is in the center. And you can maybe even draw like a line right there for z equals 0. And then I do a problem where I ask you, what is the amount of area to the left of the z-score, z equals +1? And so in order to do a problem like that, it's helpful to kind of mark off where z equals 1 is. Z equals 1 is right there. And then if I'm asking you the amount of area to the left of z equals 1, it's helpful if you kind of draw a line there and you shade everything in. We're calculating the amount of area to the left of z equals 1. One of the reasons that's so helpful is because when you do this, it allows you to see certain properties of the answer. For instance, looking at this, we can tell, will the probability be smaller, less than, or greater than 50%? Will the area to the left of z equals 1 be less than or greater than 50%?
Greater than.
It is greater than 50%, and you can see that here. And so one of the reasons it's nice to draw these pictures for any of these probability problems is if at the end of the answer you're like, well, the answer is 16% is to the left. If you were tempted to give that answer of 16% or something like that, you would look at this drawing that you just made and go, well, that's not reasonable because I'm looking at this drawing right here, and it's clear that the majority of the area is colored in this picture. So it's unreasonable that the probability would be less than 50%. So whatever my answer is, I can tell by looking at this, it should be a number which is, greater than 50%. So it's always helpful to draw the distribution, draw where the z-score that you're calculating the probability is relative to that distribution, and maybe even color in the exact area that you're trying to calculate. Okay, so yeah, here's where we're gonna do some practice problems right here. Let's see, how many do we have? Yeah, we have some practice problems. I guess I'll do most of these, but I might ask you guys to help me for some of these. So let's see. I'm gonna take a picture so I can be not on the screen and still see the problems that we're doing. You might want to take a picture too, because I'm gonna be clearing off of this screen here in a second and going to the whiteboard. Okay, so the first question that we're going to ask is, how much area is to the left of a z-score of negative 2.05? How much area is to the left of negative 2.05? So before we even begin, is the answer going to be less than or greater than 50%?
Less than.
It will be less than. And let's go ahead and draw it. Back to the whiteboard now. So here's the distribution on my whiteboard. And if the center is right there, z equals -1 would be about right there, probably z. Oh wait, we're doing z equals -2.05. So it would be like right around here. Z equals -2.05. That's the number that we had, right? Yes, z equals -2.05. And so we would color in the amount of area right here. And as the student correctly said about a minute ago, you can see that the amount of area that we're coloring in is clearly less than 50%. A very small percentage of the normal distribution lies to the left of the z-score of -2.05. But now we need to go ahead and look at our z-table because we're trying to find this exact proportion, the exact percentile, the exact amount of area to the left. And to do that, let's go back to here. To do that, we're going to go back to our z-table right here. And what we need to find is the z-score for -2.05. So right here, we're looking at the positive z-scores, so we need to go up. So we need to find -2, but we need to find negative 2.05. So the 0.05 is up here at the top. So it's this black column right here. Notice how it goes black, blue, black, blue. So this column right here. So negative 2.0 intersects with the 0.05. So this thing right here, that is the answer. And if you're curious, that says 0.0202, which if you want to know that in terms of percent, that is basically 2.02%. That's the answer. Any questions or comments about how I calculated the answer for that first one? Once again, that was looking at the slides here, that was the amount of area to the left of z equals negative 2.05. Any questions for that one? Okay, so now the other problem, the second problem was the amount of area to the right of z equals negative 2.05. So looking at the instructions that I gave you in the slides, which I'm not going to go back to. Let's see, what are we on right now? Yeah, I guess I can look at that stuff real quick, actually. So the next problem is the amount of area to the right of that same z-score, negative 2.05. To do this, we're going to take 1 minus the percentile that we just calculated. So for this, now what we're trying to do is I'm going to erase this because for the second problem, we're now trying to find the amount of area to the right of the same z-score. So when we're calculating the amount of area to the right, someone tell me, should this area be smaller than or greater than 50%?
Greater than.
It should be greater than. And the way you'll actually calculate the answer, let me show you the way I've colored this in on my. That's what I just colored in. So here's the same z-score right here. Z equals negative 2.05, but we're now calculating the amount of area to the right. We know that the amount of area to the left of that z-score was 2.02%. So the way that we would calculate the answer, the way we calculate the amount of area to the right, does anyone remember what I said we would do for this one? What's the strategy?
You would take 1 minus the percentile given
Yep.
for negative.
Exactly. 1 minus that. So that we can go ahead and type that into your calculator. I'll do it right here too. I don't have the answer right in front of me, so I'll just go ahead and calculate it with my phone calculator right here. 1 minus 2.02. Whoops. I guess I should do 100 since it's 100% minus 2.02 equals 97.98% of the area lies to the right of the z-score of negative 2.05. 97.98%. If you take 100% or 100, so I guess it should actually, yeah, I should probably have written it like this. 100% minus 2.02%. The answer is 97.98. 97.98% of the area is to the right of that z-score. Any questions or comments so far? Let's do some more practice then. Let's go back to the slides. Okay, so I want you guys to do some of these two right here. So first off, I guess I'll draw the distribution, but I want you guys to actually use the table. I guess I'll erase it all. So we're going to do the amount of area to the left of z equals -1 and the amount of area to the right of z equals -1. I'll draw it up here on my whiteboard for you. So here's the center of the distribution. Z equals -1 would be about right there. And so the amount of, that's it. The amount of area to the left of that is the problem number 1. So the amount of area to the left, we know that that number is going to be less than 50%. That's problem number one. For problem number two, you're going to calculate the amount of area to the right of that, which we know is going to be greater than 50%. So I want you guys to go ahead and by yourselves, try and get this problem right. So spend about 30 seconds to a minute to get this one right. And then we'll go over the answers together. So spend about a minute trying to get the answer to the amount of area to the left of z-score of -1 and the amount of area to the right of that same z-score. Does anyone think they have the amount of area to the left of a z-score of -1.00?
15.87%.
Excellent. The answer is 15.87%. And the way to do that is you look up the z-score of -1, which is right here. And then the 0.00 is this last column over here. And if you look at this, it says 0.1587 right there, which if you multiply that times 100 to give you the percentile, that gives you 15.87% of the area underneath the normal curve is to the left of the z-score of -1.00. So given this, how would we calculate the amount of area to the right of that same z-score?
100 minus 15.87.
Excellent. So let's go ahead and do that. You can do it two ways that are mathematically similar. You can either take 1 minus 0.1587, or you can, that's like decimal form, or you can multiply both of these things by 100, which would give you 100 minus 15.87. Both of those answers are equivalent, so you could do either type of thing. The bottom one right here, this is like the percentages right here. These are the decimals right here. So either of those would give you the answer. Can someone tell me what happened? What do you get when you do take 100 minus 15.87?
0.8413.
Yep. 84.13%, or you could say 0.8413. Either of those would be considered correct. 0.8413 or 84.13%. 84.13% or 0.8413. So good. It sounds like we are understanding how to calculate the amount of area to the left and how to calculate the amount of area to the right of a given z-score. So the last example that we're going to do here will be, let's go back to the slides. Okay. So for the last one, let's see where it go. Here we go. The last question for us to answer, the last two questions will be, how much area is between z-score of -1.00 and positive 1.00? So to remind you of the strategy for this one, what we're going to do is we're going to look up the percentile for each of these z-scores. But remember, we're not looking for this answer. We're looking for the amount of area in between those two z-scores. So the way we do that is we're going to subtract those two percentiles from each other, and the resulting difference is the answer. So let's go ahead and go to our z-table. So we have to look up two z-scores for this problem. Z equals negative 1.00 and positive 1.00. So negative 1.00, let's see, where are we for that one? That's the one we were just on. So the percentile for that one is 0.1587, which is equivalent to 15.87%. That's the percentile for z equals negative 1.00. Can someone tell me, can someone go ahead and do this? Can someone look up the percentile for 1.00 for the positive one and tell me what the percentile is for positive 1.00?
86.21%.
It is actually not that. And I kind of knew that this one would be tricky. I need you, when you're doing this one, to look at on the positive side up here. I need you to notice that up here, the decimals are in a different order than they are in the negative side. So on the negative side, the 0.09 is on the left and the 0.00 is on the right. But I need you to notice that on the positive side, the 0.00 is on the left and the 0.09 is on the right. So can we try that one again? I totally understand why that answer was given, but what is the actual amount of area to the left of z equals 1.00?
84.13%.
That's it right here, and I'm circling it right here, and I'm going to write it down. 0.8413. That is the amount of area. And so now I'm going to go to my whiteboard for you. I wrote those two numbers down. The top number is the amount of area to the left of z equals -1. The bottom number shown there is the amount of area to the left of z equals +1. And what do we do with these two numbers to calculate the amount of area in between them?
Subtract them from each other.
Exactly, 0.8413 minus 0.1587. You could also say 84.13% minus 15.87%. Those are mathematically equivalent statements. Could someone go ahead and do that and tell me the answer?
.6826.
That's what I got, 0.6826. And if this number should feel kind of familiar because at the very beginning of class, it said, I asked you the question of how much area is between a z-score of -1 and +1. And they approximated it in the picture that I showed you, but it was 68%. In fact, I want to go back to that. We just verified. So when you subtract these two numbers, 84.13 minus 15.87, we get 68.26%. Once again, that's 68.26%. And if we go back to our slides from earlier today, right here, the beginning of class, I said, how much area is between -1 and +1? And you can see right here, there's 34% on this side, 34% on this side. If you add those two things together, that gives you 68%. So on this picture, they're taking off the decimal places. They're just rounding to the nearest one, to the 4. Technically, the amount of area between these two is 68.26%, and we just verified that using the z-table. So I think we got maybe one more practice. Okay, so I want one of you guys to do the entire one now for this last one. So for this last problem, how much area is to the right of a z-score equals 2.00? How much area is to the right of z-score 2.00? Make sure that on the positive side of the z-table, you're looking up the correct z-score. Make sure you're not looking up 2.09, which is a common mistake when people are looking at positive z-scores. But look in the z-table for 2.00. Find the percentile, and then you'll take 1 minus that percentile, And then that should be your answer. So you guys go ahead and do that by yourselves. I'll kind of do it by myself too. And then I want someone to give me the answer. So take about 30 seconds here to a minute to try and get that done. The amount of area to the right of Z equals 2. Anyone think they have the answer for this one correct?
2.28%.
That is correct. Can you tell me, can you walk us through how you got that?
The percentile for 2.0 is 97.72.
Which is
Take
right.
100,
Yep.
100 minus that. Which
Yep.
is,
So I'm circling that percentile right here. You can either take 1 minus 0.9772, which would get you 0.0228, or you could take 100 minus 97.72%, which would give you 2.28%. So basically the answer for this problem, yeah, I'll show you the math here. Let's see. That's it right there. 1 minus 0.9772 equals 0.0228. You could have also done 100 minus 97.72, which would give you 2.28%. But this right here, this decimal is equivalent or equal to 2.28%. So we've done a lot of examples of this. I think I'm going to, yeah, let's go ahead and do this problem. I want you guys to do this one too. So let me show you what I'm looking at here. I've moved to the next slide in the slides. And so this one, the question is, it says for an IQ distribution where the mean equals 100 and the standard deviation is 15, what is the probability of a given person having a score which is 100 or 120 or less? And then likewise, we could also calculate 120 or greater. But I want us to first calculate the percentile of a person in this from this population who has a score of 120. If I ask you the question, what is the probability of a given person having a score of 120 or less? That's basically asking, what is the amount of area to the left of that score? And in order to do that, basically what we're going to do is we're going to calculate a z-score for this number, for the single score right here. And then we're going to use the z-table to find the percentile for this, the amount of area to the left. So let's kind of do this one together. Can anyone tell me, how would we set up the problem to calculate the z-score for this problem? How would we fill things in for the z-score formula? Can someone remind me, what is the z-score formula that I showed you? If you have single score, we have a score, meaning a single score of 120. What is the z-score formula that we use when we have a single score?
Z equals X minus the mean over standard deviation.
Yep, z equals x minus mu over the standard deviation sigma. And so all we really have to do for this problem is plug things in. And so the x value that we want is 120. And then what did I say the mean was? I don't have it in front of me. What did it say the mean was? Anyone remember?
100.
Yeah, it was 100. And does anyone remember what the standard deviation was?
15.
15, good. So this is how you would set that up to calculate the z-score. The x value that we're interested in calculating, 120 minus the mean, divided by 15. So we should already know, by the way, we're going to have a positive z-score because 120 is greater than the mean, which means that this person's percentile, whoever scores 120, should be greater than 50%. They're in the upper half of their class, so the percentile should be greater than 50%. So what do you get when you do the z-score? When you calculate z for this, what do you get? You get 20 divided by 15. What is that? 1.33. So this z-score equals 1.33. So that's the z-score for this problem. Let's go back to the slide. So the z-score for this problem is 1.33. So now the question is, what is the probability of a given person having a score which is that number or less? The way to do that is to look up the percentile for 1.33. So can someone look up on the z-table? What is the percentile for a z-score of positive 1.33? Can someone look that up for us?
.9082.
Exactly, which is right here. I'm circling it right here. 0.9082. I'm circling it right here. It's because 1.3 on this side, 0.03 on this side. So this right here, this is 1.33 is right here. The amount of people that scored 120 or less was 90.82% of the people. So the percentile was 0.9082 or 90.82% had scores that were z-score of 1.33 or less. Knowing that, how would we calculate the amount of area, the percentile, or the amount of area to the right of this number?
1 minus 0.9082.
Yep. So if we want to calculate the amount of area to the right, it would be 1 minus 0.9082. 1 minus the number that I'm circling with my mouse right here. I'm going to go ahead and do that. 1 minus 0.9082, which gives you about 9.18%. .18% is to the right of that, which makes sense. If about 90% is to the left of this z-score, it makes sense that about 10% would be to the right because the total distribution has 100%. 90% is about 90% is to the left, which means about 10%, or here is 9.18%, is going to be to the right. So that seems like it's probably a good place to stop for the day. Let's see. Yeah, we'll start out with some of these next time. We'll start out with. No. Please turn off those microphones, people. Okay, so yep, that's probably a good place to end for today. So once again, for students that want to talk about their test, you have to send me an email and we can make up a meeting. We'll be continuing on this Chapter 7 discussion Wednesday. I will be posting the recording of this lecture and discussion on YouTube after my 10 o'clock class. Just let me know if there's things you want to talk about, send me an email and I'll see you later.